Half-range cosine Fourier series. What is half-range cosine Fourier series? If the periodic function f of x is even, then I have the value for a sub naught, which equals to 1 over pi times integral of f of x dx. Similarly, I have a sub n equals to 1 over pi into 2 times integral of f of x times cosine x dx, which equals to 2 over pi into integral of f of x times cosine x dx. Half-range cosine is nothing. If you have an even function, you have the value for the coefficient a sub naught and the value for a sub n. So it means that you have only cosine function, there is no sine function. And that is the reason we call it half-range cosine Fourier series. Because sine function is 0 here. It is when the function is even, remember. We have already discussed the even function in the previous lecture. Half-range sine Fourier series. If the periodic function f of x is odd, then b sub n equals to 2 over pi into integral of f of x times sine n x dx. If the function is odd, you have only the value for b sub n, which is sine function. Therefore, it is called a half-range sine Fourier series. Because I have only sine function, my cosine function, which was in a sub n, is 0. And a sub naught is also 0. I have only sine function here. Therefore, it is called half-range sine Fourier series. I have already taught you about half-range sine series and half-range cosine series. Now I'm gonna talk about full-range Fourier series. What is full-range Fourier series? If f of x is a complete cycle of the range from minus pi to plus pi, or from 0 to 2 pi. Let me show you graphically. Here is a wave, 0 at origin, and its range is from minus pi to plus pi. So this is one complete cycle. Therefore, it is called full-range Fourier series. If you reflect back, we had half-range sine series, which means that there was only sine function. And similarly, we had half-range cosine series, where we had only cosine function. Here we have full-range Fourier series. So which means that we have both sine and cosine functions here, because we talk about the complete cycle. So if the function has a complete cycle, then a sub naught equals to 1 over 2 pi times integral of f of x dx with a range from 0 to 2 pi. It's up to you, you can also take from minus pi to plus pi. Similarly, I have a sub n equals to 1 over pi times integral of f of x times cosine x dx with a range from 0 to 2 pi, and also b sub n, which equals to 1 over pi times integral of f of x times sine n x dx with a range from 0 to 2 pi. So here I don't talk about the even and odd function or half-range sine series or half-range cosine series. I talk about full-range Fourier series, where I have both sine functions and cosine functions. Therefore, I have all the three coefficients of Fourier series, a sub naught, a sub n, and b sub n. The function f of x is a complete cycle with a range from minus pi to plus pi or from 0 to 2 pi. So I have all the three coefficients of Fourier series, a sub naught, a sub n, and b sub n.